Alright, I'm going to jump ahead just because we're going to see these ideas of inequalities pop up again, and I think it'll be a good reminder of how we solve like quadratic equations. Or remember when I talked about equations, once you see a power greater than 1, this is what you always had to do. So your book titles these polynomial inequalities. Polynomial inequalities. Or I'll talk about rational ones, but I'm just gonna focus on the polynomial ones. You can also just call these nonlinear inequalities, just because they're not going to be linear. Linear inequalities are the ones we solved in 1.7. Like, for example, solving something like x plus 4 less than or equal to 3. This would be a linear inequality because we have a power of 1 here, where you would just subtract by 4, and then x is going to be... Remember, you can subtract by 4, that's fine. You just want to watch out for when you divide or multiply by a negative, but right there, that's fine. Leaves us with -1. So we still have to remember all these same properties for inequalities. Don't forget this side's a smaller, bigger. Don't forget if you multiply, divide by a negative, you have to switch the inequality, so on and so forth. But I also want to remember when we talked about the zero factor property. Remember, the zero factor property said if a times b was equal to 0, then a was equal to 0 or b was equal to 0. And that was just for, in general, it could be a times b times c times d, and that could be equal to 0. So, and this was whenever we saw a power greater than 1. That's when we did that. When you saw a power bigger than 1, that's when we did that. We would remember, the first thing was you had to set everything equal to 0, try to factor it, and then you set each factor equal to 0. So we're going to be the same way. Equations were very similar to inequalities. We just had to be careful with once we got our final answer, or if you multiply or divide by a negative. These polynomial inequalities are going to work the same way we did sort of quadratic or polynomial equations, that we moved everything over to one side, so one side was 0, and then we try to factor as best as we could, and then you set each factor equal to 0. All that's going to still be the same. The only thing that's going to change, well, you want to be careful if you're dividing or multiplying by a negative, but then the answer is going to change. It gets a little bit trickier to do this, so, but we still have to remember that there's different. We'll do an example and you'll see why. So let's start with an example. And I'm gonna try to solve these. Your book likes to use a table. I'm gonna try to see if I can do something slightly different. But here, we'll start with an example, and you'll see at first glance maybe what I'm talking about. So 3x times x minus 1 greater than, so that's the inequality part, 10 minus 2x. So hopefully at first glance, it looks almost like a linear inequality, just because everything looks like it has a power of 1. But hopefully when we see something like this, we naturally want to just do the distributive property. And once you do the distributive, before we start thinking about moving things, isolating, if we want to solve for x, you want to make sure you try to get x out of those parentheses. So this is what we get now. We have 3x squared now. And that's what I was talking about when we use the zero factor property. As you see, as soon as you see a power greater than 1, this is what you resort to. That's what we did for when we're dealing with quadratic equations or any polynomial equation. Or it technically works for any equation that has a power greater than 1. That's what you want to try to do. So then we get negative 3x distributed greater than 10 minus 2x. So the fact that we see this square here, that's when we want to resort to the zero factor property. The very last part is when it's a little tricky the way we solve these, but at the beginning a lot of it behaves exactly the way we were doing things before. So hopefully it's a good reminder of how we did things when we saw that. So I have to try to move everything over, and remember, you usually want your leading term to be positive. So I don't really want to be moving things to the right just because that's positive already. I'd rather move all of these to the left. So I do that by, I can subtract 10 to both sides. Remember, here's your inequality. You would do it on this side. And then we're going to add 2x to both sides. So that the 3x stays exactly the same. That's not changing at all. The 3x squared. But now this negative 3x and this 2x simplifies to just negative x. And then there's this negative 10 that's just on this side. Now, here that's 0, and that's greater than 0. Again, we didn't multiply or divide by any negative, so this inequality doesn't have to switch. Again, this looks a lot like what we were doing before. Now, we just want to, we're going to continue this up here. Now, you want to try to factor this left-hand side. And remember, when you're factoring, the first thing is always GCF. Second thing, 4 terms, 3 terms, 2 terms. So, GCF, x squared x, no x's, no GCF. 4 terms, there isn't 4 terms, but there's 3 terms. So then that means we're going to use the x. So then remember, we have to take 3 and negative 10, which will give us negative 30. Sorry, I keep moving the paper. Negative 30. And then the middle number is negative 1. Remember, we have to think of 2 numbers that can multiply to negative 30, but add up to negative 1. Alright, so, and remember, we want this one to be negative, and then this has to be negative. So that means one of these has to be negative, the other one has to be positive. And we think of the only factors of 30 is 5, 6, 10, 15, 2, 30, and negative 6 and 5 will do the job. So let's factor that. Again, we should be able to do this quickly. So 3x squared minus 6x plus 5x minus 10 is greater than 0. And remember, we like to group the first two, group the second two. Remember, I like to grab the sign just to remind me that it was positive. I always put a plus there to make sure they're not multiplying each other. Now the GCF here is 3x. Now we're left with x minus 2. GCF here is 5. And I'll just take out a positive 5. I'm left with x minus 2 greater than 0. And GCF here is x minus 2. So I have x minus 2 times 3x plus 5 greater than 0. Now, again, everything is exactly how we were doing before. I'm now going to take this and set each one equal to 0. 3x plus 5 equal to 0. Again, I just want to know, because the fact that we have a 0 on this side, remember, now this is where you need to start thinking about what the inequality is asking for. If we think about, remember, it opens up, this has to be the bigger side, this is going to be the smaller side. So that means we want the values of x that make these give us numbers that are bigger than 0. And if we think about what numbers are strictly bigger than 0, that's going to be all the positive numbers. So I just want to know where I get 0. So then I just want to know, I want to get values that actually give me positive. So that's where it changes up. Everything so far was exactly how we would solve a quadratic equation. Same here. Everything is still the same. We add 2 to both sides. Here you would subtract 5 to both sides. Here I'm left with x is equal to 2. On this side, there's a little more work. It's 3x is equal to negative 5. And then I'll divide by 3. And that leaves me with x is equal to negative 5 over 3. So, now, the way we solve inequalities was looking at a number line. So, when we did something like this over here, we drew a number line. And then we saw where negative 1 was. And then we know this says equal to that, so you end up having a closed circle here. And smaller, the numbers are smaller always on the left. So the fact that we're using graphs, let's think about a graph here. It's just going to be a little bit trickier. So this is where things are going to change a little bit. So if I don't have to put negative 5 exactly where it goes. I just know positive 2 is bigger than negative 5 over 3. But we can still think about this open circle and closed circle we were doing before. This says this side has to be strictly bigger than 0. It cannot be equal to 0. And what we just found, this 2 and this negative 5 over 3, is where we actually get 0. So actually we're going to have open circles at these places. But now I want this side to be bigger. So I'm looking for all the numbers that are positive. So this ends up giving us 3 different intervals. Here would be 1 interval, 2 intervals, and 3 intervals. We want the intervals that are actually going to give us positive numbers on this left hand side, because positive numbers are all the numbers that are bigger than 0. So then that's where we need to use test points. These test points are going to be numbers that we're going to use to just check. We're actually just going to plug in numbers into here to try to verify which values are going to give us positive ones. So let's start. So you can try using your calculator if you have one. The reason why I'm saying that is that if we think about what 5 over 3 is, look, if you see on your calculator, I'm trying to zoom in a bit, but negative 5 over 3 is equal to approximately negative 1.6. The reason why that's important is because that means the numbers on this side are going to be much smaller than negative 1.6. Then I don't want to be plugging in decimals on this side, so I'm going to choose negative 2. Since I know negative 2 is definitely smaller than negative 1.6. And then we think of in between negative 5 over 3 and 2, a nice number to use would be 0. That'd be a definitely good number. And something that's bigger than 2, we can use 3 as a test point. That'd be something that we can use. Alright. Let's actually just check. So the way we're going to check it is we're just going to plug into here. So we have our factors are x minus 2 and 3x plus 5. I'm just going to plug in all our test points. So we have negative 2 is one test point, 0 is another test point, and then 3 is another test point. And I got kind of mushy with these markers. Sorry about that. All right, so let's plug it in. So, and you don't have to get, it's not about, I don't need to know the exact number. I just need to know what sign I'm getting. Because I ultimately only, if I'm looking for numbers that are bigger than 0, I'm ultimately only worried about positive numbers. So if I plug in this -2 in here, so remember we're plugging into our x's. I know -2 minus 2 is going to still give me a negative number. But I know that whatever number I have here is multiplying with this factor. So when I plug in -2 in here, I know 3 times -2 gives me -6. Plus 5 is still going to give me a negative. And we know a negative times a negative is going to give us a positive. So that means right here on this side, all my values are going to be positive, which is something I actually want. I want numbers that are bigger than 0. So that means I want positive numbers. Now let's try plugging in 0. If I plug in 0 here, that still leaves me with a negative. I plug in 0 here. 3 times 0 is 0 plus 5 is positive. And I know a negative times a positive is negative. So all my answers in between are going to be negative. And then I put in 3 minus 2. I know it's a positive number. If I plug in a 3 in here, 3 times 3 is 9. That's a positive 9. Plus a positive is still going to be positive. And a positive times a positive is still positive. So that means any number bigger than 2 is going to be positive. So then that's when I go back to the inequality. The inequality is asking for this sign to be bigger. And the only way it's going to be bigger is if it's positive. So that means my answer is going to be anything that's bigger than 2, anything that's smaller than this -5/3, but it cannot include -5/3 and 2. And that would be your solution. Which you can also write that solution in interval notation. So if I bring this here, let me just try to put our solution here. Because this goes from -infinity and it stops at -5/3, or you can use this decimal if you want. And then this interval starts at 2 and then it goes to infinity. And remember, parentheses always around infinities. And since we have open circles right here, I have to put parentheses as well, but I'm going to add my union. And you can write set notation, but it gets kind of messy, so I'm okay with interval notation for these. You'd have to try to find 2 different inequalities that represent this, so I'm okay with either one of these 2 answers. Oops, sorry. Let me fit it there. Well, let me write it again. So it would be -infinity, -5/3, union 2 to infinity. That'd be the answer. Or if you graphed it, this would work too. But yeah, it's kind of messy. There's a lot going on. So let's do another example. Hopefully that helps. So again, everything up to here, before we start, this is all the new stuff. Everything was exactly how we did before when we were dealing with quadratic equations or equations that had a power greater than 1. That was let everything be equal to 0. Factor everything. Set each factor equal to 0. Then we had all these new ideas because we had to be thoughtful about what values of x we were going to use, because depending on what answer you wanted to get. So let's try another example. Let's do a smaller one. Maybe that was there was a lot going on with that one. Probably should have started with something a little smaller. So let's try this. Let's try y squared is less than or equal to 9. So that looks innocent enough. But like I said, as soon as you see a power greater than 1, if this was a linear inequality, like this one was. Just isolate the variable. The same way when it was a linear equation, you just try to isolate the variable. Like for example, these are linear equations. All you have to do is try to isolate the variable as best as possible. We subtracted 5 when divided by 3. So that's just isolating the variable. But yeah, as soon as you see an inequality or an equation that has a power greater than 1, we automatically have to resort to try to moving everything over to one side. Remember, we usually want our leading terms to stay positive. So I'm going to subtract 9 to both sides. That's going to leave me with y squared minus 9 is less than or equal to 0. Again, eventually we'll worry about this. Remember, this was, and now it's going to be our smaller side. This is our bigger side, or they can be equal to each other. But for now, just imagine if this was a regular quadratic equation you're trying to solve. That means we have to try to factor this left-hand side. And hopefully while I was talking, you guys noticed what this y squared minus 9 is. And that's the difference of squares. So that's y minus 3, y plus 3, less than or equal to 0. So then I have y minus 3 is equal to 0. Y plus 3 is equal to 0. So I just take each factor and set each one equal to 0. All this is exactly how we did before. Hopefully you guys can recall. So this is just going to give us y is equal to 3. And this is going to give us y is equal to negative 3. When this was quadratic equations, we stopped here. Those were our solutions to our equation. But since this is an inequality, when we first were looking at inequalities, the way we solved them was looking at a graph. So let's look at this. And remember, the only numbers we have to reference is negative 3 and 3. Just like before, now I have 3 intervals again. But if we look back on our inequality, now we want to start looking back at what our inequality is asking for. The marker's dying out. This inequality is looking for numbers that are less than or equal to 0. Since it wants numbers that are equal to 0, what we just did here is that we know at 3, if I plug 3 in here, 3 squared is 9, 9 minus 9 is 0. So that means I'm going to actually have closed circles at negative 3 and 3. Because at these values, we actually are going to be equal to 0. And that's why because we're trying to reference 0. Again, if we think about what are the numbers that are smaller than 0, those are the negative numbers. Before, it's kind of cluttered, but we're looking for the positive answers. Now we're going to want that negative. And let's see what this negative ends up being. But we need to do our test points. So let's move over here and let's think about what test points we want to use. And then we have our factors. So we're going to put that here. Our factors are y minus 3 times y plus 3. Remember, they are multiplying each other. So if we think about what's a number smaller than negative 3, we can use negative 4 for this interval. We can use, again, 0, because in 0, always try to use nice numbers. Don't try to get creative and like, let me use negative 4.3297. Just use something nice. You don't want to spend too much time with a weird number. And then numbers that are bigger than 3, we can try using 4. So if I think about plugging in, so remember, this is coming from this side, this 0 is coming from the middle, and this 4 is coming from this right hand side. When I plug negative 4 into this y, well, negative minus a negative is still going to be negative. I'm mainly worried about the sign and not so much the number. If you want to get the exact number, well, -4 minus 3 gives you -7, but I care more about the sign. And that's multiplying with, if I plug -4 in here, well, -4 plus 3 also gives me a negative number. And a negative times a negative is positive. So I know everything on this side is positive. I probably should have done it under so I don't get in the way of my graph. Now when I put in 0, 0 minus 3 is still a negative number. 0 plus 3 is a positive number. That's going to give me a negative. I plug in positive 4 here. 4 positive 4 minus 3 is a positive. And I plug in a 4 here. That's going to be 4. Oh, sorry. It's going to be positive because 4 plus 3, a positive plus a positive is still positive. And then a positive times a positive is positive. So I forgot to say here, in this interval it's negative, and in this interval it's positive. But if we look back, we have closed circles at 0 because we want it to actually be equal to 0, but we want y's that are less than 0. So that means things that are less than 0 are negative numbers. So that means the only negative numbers are right in between -3 and 3. So that would be your graph. And your interval notation for that would be from -3 to 3. But since -3 and 3 are both included, meaning that if you actually plug them in, it's still going to be a true statement. So I'm going to put brackets around them. So again, the first part of this is exactly what we did before. Move everything over to one side. Try to factor. Set each factor equal to 0. And then but since this is an equality, you want to start thinking about your graph and what your graph is doing. So determine if you have, depending how many, what are these? These zeros that you got, how many of them? You're going to put that on your graph, how many numbers you have to reference, and then decide if it says equal to, that's where these actually equal 0. If it doesn't have equal to, that means we're going to have open circles. If it said equal to, we'll have closed circles. So let's look at an example that doesn't even involve any factoring, because hopefully we remember this part. But let's look at an example that's already factored for us, and all we have to try to do is find our answers. So for example, x plus 2, x plus 5, x minus 4 is greater than or equal to 0. Now that I'm thinking about it, maybe I should have started with an example like this. But hopefully I didn't confuse anyone too much. The reason why I'm saying is because this is already everything that you did up to here. We should know how to do, which is move everything over to one side so it's 0, factor everything as much as possible, and now the only extra part you should do now is take each one of these and set them equal to 0. So that would be x plus 2 is equal to 0, x plus 5 is equal to 0, x minus 4 is equal to 0. So then that here we're going to get x is equal to -2. Here's x would be -5 because we would subtract the 2 over. We would subtract the 5 over. Here we'd add the 4 over, so we'd get 4. So now is when I can make my number line. So let's do that. It's going to be a little bit bigger just because now we have a -5. I know is smaller than a -2. And I know positives are always bigger. And at these points is where your inequality is going to be 0, or this left hand side is going to be exactly 0. And we actually want it to be equal to 0. So that means we're going to have closed circle at each one of these numbers, at these zeros. But just like before, we want to be able to do our test points now. Again, if we look at our factor, that's going to be x plus 2, x plus 5, x minus 4. And then start thinking about what you want your test points to actually be. So let's close this up here. So I know things that are smaller than -5 are -6. Something in between -5 and -2 would be -3. Something in between -2 and 4, since it goes from negative to positive, I know there's a 0 in between. And anything bigger than 4 can be 5. Now we just have to plug into these to see what we're getting. If I plug -6 in here, I know I'm going to -6 plus 2. I always keep the sign of the bigger number. Times, if I plug a -6 in here, I also get a negative. I plug a -6 in here, I also get a negative. And here I'm getting a negative times a negative, which is positive, times another negative, which is negative. So everything on this side is negative. Oops, sorry. Now, plug in -3. That's a negative. I plug -3 in here. It's going to leave me with a positive. I plug -3 in here. I'm going to be left with a negative. Because -3 plus 2 is negative. -3 plus 5 is positive. But -3 minus -4 is still going to be negative. And a negative times a positive is negative times a negative is... What did I say? A negative times a positive is negative times a negative is going to leave you with a positive. So everything in between -5 and -2 is going to be positive. And then now we have to try another test point. So then we have, if I plug in 0 here, that's going to be positive. Times I plug in 0 here, that's still going to be positive. Times I plug in a 0 here is going to be negative. And a positive times a positive is positive. Times a negative will leave you with a negative. So everything here is negative. And then our last test point, I plug in 5 here, I get a positive. I plug in a 5 here, I get a positive. I plug in a 5 here, I also get a positive. Times positive is still equal to a positive. So everything here is going to be positive. Now, let's look at what the inequality was asking for. Let me put these down. I dropped the cap. Let me pause. Alright, look at what our inequality was saying. Has to be greater than or equal to 0. Well, equal to 0, that's why I have all these closed circles. But remember, this side is the bigger side. And if we think about what numbers are bigger than 0, those are all the positive numbers. Positive numbers. So that means our answers are going to be in here and everything above 4. So if I write that in interval notation, this interval here is from -5 to -2. And then a new interval from 4 to infinity. Again, we have closed circles at -5 and -2 because this is equal to. So that means I'm of a bracket. And then a bracket. And then 4 also have a closed circle. So hence that's going to be a bracket. But we always put parentheses around infinity. And then you have to just put your union. And that's what our solution will look like. I want to do one more very quick example. Just to illustrate something important. Here, for the sake of time, I wrote it. I paused the video and I wrote it. And then for a little more sake of time, this is already equal to 0, all you have to do is factor this, which this will factor into 2x minus 3. Again, you can try this when you're watching the video, try to factor it, see if you can actually get this answer less than or equal to 0. And both of these are exactly the same. So both of them, again, you can set each one equal to 0. For the sake of time, we have 3 over 2. And that means we only have one number to reference. And that's perfectly okay. Since that means we have equal to, that means we'll have a closed circle at this 0. Because if you add 3, divide by 2, you'll get 3 over 2. But then when I look at my test points, so then we have these two factors are the same. You can also rewrite them as a square, and that illustrates something important. I'll talk about it, but since we've been doing this, writing each factor, I want to keep it consistent. And number that's smaller, remember this is 3 over 2, so this is approximately 1.5. I know 0 is definitely smaller than this, so I'm going to use 0. And I know 2 is bigger than 3 over 2. Because 2 is like saying 4 over 2, which is bigger. So, and then if you want, you can check that. This 2 is bigger, so it's going to be on this side. This 0 is bigger, so it's going to be on this side. So 0 is a test point here, and 2 is a test point here. But when I plug in 0 here, that's going to give me a negative. And whatever I get for this one, it's going to be the same thing. So that's going to give me a positive answer. I plug in 2 here, it's going to give me a positive because 2 times 2 is 4. 4 minus 3 is positive. And I'll get the same thing because this is giving me the same one. And that's going to give me a positive. So for both of these, I'm getting positive answers. And if I look back at my inequality, so this is why it's different than just an equation. And we think about the last section of absolute value inequalities, that we had to be thoughtful because here it's just with inequalities you have to put a little more thought to them. The equal to part that's the reason why I have a closed circle. But I also want this side has to be, because this inequality closes, this is the smaller side, this is the bigger side. So what numbers are smaller than 0 are negatives. And I know on this side I'm getting only positives, on this side I'm only getting only positives. So the only solution is this 3 over 2. The only solution for this inequality is 3 over 2 because we aren't getting any actual negative answers here. If there was no equal to part, this would actually have no solution because there would be no value of x that would actually make a negative in here. Nothing whatsoever, because that's saying anything over here to infinity is positive, anything over here to infinity is positive. Only right here is this 0. If this had said less than or equal to, this would have no solution if it said that. But since it says equal to, that's the only solution is the 3 over 2. If it didn't have the equal to, if it was just a strict inequality, there would be no solution to that. And see, what would the solutions be if this was, think about that. Say if you do the exact same problem, but switch it to less than 0, greater than 0, and then greater than or equal to 0, and see how, and then you'll put this side, put it right here, and see how that's going to change. Or maybe I should say this portion here. You're going to switch. And think about how your answers will change. So try to do that for homework. See what you guys think. Let me give you some homework really quick. Alright, here's your homework. Sorry, I just paused it to write it. But it's 3.6. That's 21, 22, 25, 40, 48. And here's some couple extra problems. I'm going to zoom in. Try to solve these and see what you get. So that's 2x times x minus 1 less than 21 minus x. These two are the same. 25x squared minus 10x plus 1 is just less than or equal to 0. Greater than or equal to 0. And just I wanted to add this part here, you can write as 2x minus 3 squared. And what you could have seen is that whenever you square anything, it makes everything positive. So we already knew anything that came out was going to be positive already. If that doesn't make any sense, just do it like the way we did before. Other than that, thank you. If you have any questions, please email me or come to my office hours that I send emails for. Bye-bye.